We're going to continue discussing complex numbers. We have added and subtracted during class. We're going to take a look this evening at multiplying and dividing them. Multiplying, I think you'll find something similar. You can see here, we're going to use the distributive property and the FOIL process to multiply complex numbers. Just a couple of different types of examples you may see up here. First one, we have 5i times the quantity -2 plus I. So here we use the distributive property, distribute that 5i inside there. 5 times -2 is -10, and we keep the I there. Positive 5 times positive 1 is plus 5. And then we have I times I is I squared. Please recall that I squared is -1. So this is -10I plus 5 times -1. And we simplify this. I'm going to write the real part first. -5 plus, minus 10I. 5 times -1 is where the -5 comes from, and then minus 10I. That would be the simplification for that particular problem. Just the distributive property, and then we have to recall that I squared equals -1. Remember, I squared equals -1. As we look over here to the next couple, we'll start up top. The quantity 7 minus 4i times the quantity -1 plus 2i. We're going to FOIL. 7 times -1 is -7. 7 plus 2i is 14i. -4 times -1 is positive 4i. And then -4 times positive 2 is minus 8i squared. So we now simplify this. The -7 stays as it is. 14i plus 4i is plus 18i. And then -8 times -1 is positive 8. Because remember, I squared is -1. So -7 and positive 8 will give me positive 1 plus 18i. So we simplify that down there. This next one, hopefully you notice it's a special case. We have 6 plus 3i and 6 minus 3i. This will get a special name here when we go over dividing. But again, we FOIL this. 6 times 6 is 36. 6 times -3i is -18i. 3i times 6i is plus 18i. And then positive 3i times -3i is minus 9i squared. Please notice here on the inside that the 18 and -18 will cancel out. So we'll end up with 36 minus 9 times -1 is plus 9. This actually equals 45. It just equals a real number. So that's multiplying complex numbers. We FOIL or we distribute. And then we have to simplify a decent amount, but nothing overly difficult, adding and subtracting there. Dividing complex numbers is a little more challenging, at least initially, because in order to divide complex numbers, you actually multiply the denominator by its complex conjugate. What is a complex conjugate? Well, if you look, it's wrong button. These 6 plus 3i and 6 minus 3i, that's a complex conjugate. So as we look here, a plus bi and a minus bi. So what we actually have to do in order to divide, we have to multiply the top and the bottom of this particular fraction by the denominator's complex conjugate. So right now I have 1 minus 2i. My conjugate is 1 plus 2i. 1 plus 2i. So now we FOIL in both cases. The numerator, 5 times 1 is 5. 5 times 2i is 10i. 3i times 1 is 3i. And then 3i times 2i is plus 6i squared. That's my numerator. That's my numerator. My denominator, 1 times 1 is 1. 1 times 2i is plus 2i. Negative 2i times 1 is minus 2i. And then negative 2i times 2i is minus 4i squared. Now we simplify. First the numerator. 5 plus 13i. 6 times negative 1 is minus 6. We have that. We end up with 1. Those cancel. Negative 4 times negative 1 is positive 4. Numerator, 5 plus negative 6 is negative 1 plus 13i. The denominator is 5. So hopefully we're starting to realize that when we multiply by a complex conjugate, all we do is we do 1 plus 2 squared. 1 plus 4, we get 5. This would be our simplified answer for this first one. I know that complex conjugate's a little difficult at times, so we're going to do 2 more examples with it, at least one of them, see what our time's like here. But we take a look at this first one. We have 1 plus I in the denominator. The complex conjugate of that is 1 minus I. 1 minus I. Numerator, 2 times 1 is 2. 2 times negative I is minus 2i. Negative 7 times 1 is minus 7i. And then negative 7i times negative 1i is plus 7i squared. Now, denominator, I'm going to show you the shortcut. Since it is a complex conjugate, we'd have 1 plus 1. Because 1 squared is 1, and then 1 squared is 1. So we have that there. We simplify the numerator. We have 2 minus 9i minus 7 all over 2. And that simplifies down to negative 5 minus 9i all over 2. And that would be our final answer for that division of complex numbers. One more to go here, and we'll go through this one. We do have time for it. A little tricky. We have negative 1 minus 2i. Remember, the negative 1 doesn't change, only the plus 2i. So the complex conjugate is negative 1 plus 2i. So negative 1 plus 2i is what we multiply by there. Our numerator, 3 times negative 1 is negative 3. 3 plus 2i is 6i. 11i times negative 1 is minus 11i. And then 11i times 2i is plus 22i squared. I'm going to go ahead through with the denominator here, but our denominator, if we use the shortcut, we should have 1 plus 4. We should have 5 down there, because negative 1 squared and 2 squared. We get 1 plus 4. But let's go through. Negative 1 times negative 1 is 1. Negative 1 times positive 2i is minus 2i. Negative 2i times negative 1 is plus 2i. And then negative 2 times positive 2 gives me minus 4i squared. We'll simplify the numerator. Negative 3 minus 5i minus 22 all over. We have 1 plus 4. So we end up with negative 25 minus 5i all over 5. Now typically we've been done here, but everything is divisible by 5. So we can simplify. Negative 25 divided by 5 is negative 5. Negative 5 divided by positive 5 is minus 1i. Final answer, negative 5 minus I. That's all we have for complex numbers tonight. We will continue practicing these tomorrow during class.